If you can't hear me in the back, raise your hand, then we'll adjust things so that you can. Welcome back, welcome back. First thing to say is after class last week, some people came up to me and they said, "You're going to be charged with murder. We're dying out here. Please give us a break." So we're going to give you a break today because prison's awful. And so somewhere along the line, somewhere around the 50-minute mark, give or take, we'll have a 15-minute break. So people can survive the class. I know it's a little hard to listen to somebody ramble for that long. Okay, so where were we? We were doing our first model, and our model is an attempt to understand something about the real world, right? Now, we have to choose our something very carefully because the real world is complicated, and we can only understand so much in one go, right? So we're picking one particular thing, which is going to be this multiplier idea, which we haven't gotten to yet. And the way we did this is we've created a story for how people behave. Okay? Now, you can buy the story or not, and you should decide yourself whether you do or you don't, how much it's leaving out. Does it capture something real? Doesn't it capture something real? These are all viable questions. It's it's easy to criticize it now. When we come to the punchline, then you can see how much you buy the punchline because the punchline is based on this. But our little story is people look at their current income and use that to decide how much to buy. So it's a story about consumption. And the story is that as they get a little richer, we're thinking disposable income, the income they make minus the taxes, right, what they get after taxes. As they get a little richer today, they spend some of it and they save some of it. And so this little c, this marginal propensity to consume, is somewhere between 0 and 1. And empirically, something about like 0.9, 0.95 is what you should be thinking. That as people get 1,000 euros richer, they save 100 euros, they spend an extra 900 euros. On average across the economy. Each individual different, of course, but on average across the economy. And we think even if they had no disposable income, they would still spend something out of their savings, right? Out of their savings. And so this is how we're going to think about our story about consumption. This is our only story we've got in this model about how people behave. Right? And if you've ever met people, I don't know if you run into people in your daily life, but the people I run into in my daily life are much more complicated and interesting than this. Right? There's a lot more going on with people than this, but this is our baseline that we're going to start with. Okay? To the extent that you think this captures something, maybe the model will capture something real. To the extent that you don't think that this is capturing anything real, the model won't capture anything real. Right? Again, it's not really useful to say, oh, there's lots of other things going on. Because of course, right? But is this something that you see going on with humans that you know? Okay? You go out and you observe the humans like an anthropologist and decide how they behave. Do they spend out of their current income? Okay? And brief argument about why it might be not horrible. And then we're going to put this together with planned aggregate expenditure. So planned aggregate expenditure is the amount that we plan on spending, obviously. And we have a whole page of math here. And rather than doing that, I'm going to do it by hand. Because I think reading math on a page is kind of useless. Nobody ever gets anything out of that. But seeing it done, understanding the steps, that can be useful. So we're going to do that. So we're starting with this with two things. We're starting with y is equal to planned aggregate expenditure. And planned aggregate expenditure is equal to C plus IP plus G plus net exports. Exports minus imports. And we've also got our consumption function, which is C is equal to C bar plus little c y minus t. Okay, so this is a definition. Right, what we've done is we've said Irish stuff gets bought by somebody. Everything that is made, whether it's physical or a service that gets made in Ireland, ends up in somebody's little mitts at the end of the year. Right? Either it ends up in the consumer, with a consumer, whoops, that's not helpful, a consumer, or it ends up with a firm, investment broadly speaking, the government, or foreigners. Right? Somebody holds it at the end of the year. And so this is just really an accounting identity. We've said everything that gets purchased in Ireland is held by a brown-haired person, a blonde person, a red-haired person. We're just dividing it into categories. No real story here. The story is coming in here where we have a motivation for people. People are going to consume based on their disposable income. Okay? And now what we want to do is we want to put those two things together. Right? Take our definition of planned aggregate expenditure and put it together with this. Now in this story, and this is important, in this story we say Y, but here we're thinking of Y as income. Right? We said there's three ways you can think about GDP. It is the stuff that gets produced, it is what gets spent on the stuff that's produced, and it's the income people get from making the stuff. Right? And so here we're thinking when people are deciding on how much to consume, they're thinking about their income. And so this is the income sort of meaning of Y here in terms of our story. Okay? We're gonna combine these things in the end, of course, but at the moment, when we're just making our story, it's really about income. People look at their income and they decide how much to spend. Okay, so now we're going to put those two things together. And so I'm just going to take this one and I'm going to plug it in. And so we get planned aggregate expenditure is equal to C. Instead of writing C, I'm going to write all this, C bar plus little c Y minus T. That's just our consumption. And then plus all the other bits. Plus IP plus G plus net exports. Okay. And now I can go on and do my thing, but I want to take a minute here and say, look, we have this thing. We have this not super complicated story about consumption, but it's a story about consumption anyway. And we got all this other stuff going on here that we got no story about at all. Right? We got this investment, no story. We got government spending, no story. We got foreigners, no story. Nothing to tell us anything about those things. Okay? So in this simple model, we are not going to be able to explain any of those things because we haven't attached a story to them. Right? There's nothing we're going to learn from them. They're going to be very wooden Asimov-style characters, whereas this will be more of a George R.R. Martin kind of character, deep and meaningful. But so we got nothing going on with those things. So they're really just constants. They're falling from the sky. Firms are investing $100 billion. Right? And we don't know where that comes from. Nothing in the model is going to change that. We are not going to understand anything about investment from this model because we put nothing into our story. We might understand something about consumption, but we're never going to understand from this anything about investment. We're not going to understand anything about government spending. We're not going to understand anything about the foreign sector. Okay? As it is, we'll trick it up later, but at the moment, we're not going to understand anything about those. So all these things, C bar, little c times minus t, investment, government spending, net exports, these are all autonomous spending. These are spending that doesn't depend on income in the silly little story that I wrote. So what I'm going to do is I'm going to put all those autonomous bits, all the bits that don't depend on income, together, and I'll just give them a name. I'll give them a letter so I don't have to carry all these bits around because they're all like identical. We got no story for investment. We got no story for government spending. So they're really doing the same thing in this model. They're not telling us anything other than there's this much spending. So let me put all those things together. And, okay, we need to disable touch input is what we need to do. Someday we will do that. Next time we will have touch input disabled. But not today, not today. Planned aggregate expenditure. And let me just put all of those bits together. So I've got C bar, that doesn't depend on income. I've got minus C times T. That doesn't depend on income. C times Y doesn't depend on income, so I'm going to take that out. But also planned investment, government spending, net exports. No story for any of these things. These are autonomous spending. And we're going to give them a letter, and we're going to give them a name, and we're going to call them E. And that is purely so I don't have to write all this stuff over and over and over again, right? There's a lot of things to write. Just give them a name, call them E, and that's great. Right? But we still have the induced expenditure, which is plus C times Y. Okay, so I haven't changed anything here, but now I have this thing, planned aggregate expenditure is equal to E plus CY, which I think you'll agree is a little easier to look at. Okay. It's because we gave it a name. Now, in this thing, on the left-hand side, we have expenditure. And I'm going to drive myself nuts. Expenditure. And on this side, we've got income. Right? And here's the big macro trick, is that for an individual, expenditure and income are different, but for the economy as a whole, expenditure and income have to be the same. Right? So we can rewrite this as Y equals E plus CY. Right? Where on the left-hand side, we have the expenditure notion of GDP, and on the right-hand side, we have the income notion of GDP. But in fact, for the economy as a whole, they have to be the exact same thing. So mathematically, we can treat them as the same thing. We can just call them Y. Okay? And then, we have an equation. With one thing we don't know income, and so we can just solve for Y, right? It's like math. Right, so now that we have this, using this super important trick, like super easy, but it's important to pay attention that something happened here, right? That here we're using the fact that income and expenditure have to be the same, and so we can do that, and we can treat them as the same. And we get, let me just write that again, Y is equal to E plus CY. And now I can just solve for Y. And so I got Y on the left, I got Y on the right. I can subtract CY from both sides, and so I get Y minus CY is equal to E. I have Y here, I've got Y there. I can factor that Y out. I get Y times 1 minus C is equal to E. And I can divide through by 1 minus C, and I get Y is equal to E over 1 minus C. Or I can write it Y is equal to 1 over 1 minus C times E. Okay. So now I've solved for equilibrium level of output, income, expenditure in this story. Right? Now a couple of things to notice is that when I was doing this division, right here, this can't be 0. Because you can't divide by 0. So in order to do this whole thing, we can't have marginal propensity to consume be equal to 1. And in fact, if it was greater than 1, then 1 minus C would be negative, and output would be negative, which is goofy as well, right? Saying we produce negative, I don't know, we could easily produce negative stuff just by tearing things down. But that's clearly not what we're after. Right? So for this whole exercise to work, we really need the fact that we've assumed marginal propensity to consume is positive, but less than 1. Right? In order to do that division. And this brings us to an interesting thing in terms of like how are we approaching this modeling. When we do these things, when we make these stories about how the economy works, we want to do them in 3 different ways. We want to tell a story where we see how humans are behaving. Haven't done that yet, right? We want to do it with a graph, because graphs are very helpful for understanding. And we want to do it with math, because math forces us to think very logically about it. It's a logical language. And in fact, we've learned something here. We assumed it was between 0 and 1 before, but now we know why. Right? And it came from this math, that this model is only really going to make sense if the marginal propensity to consume is between 0 and 1. Right? It's not going to, if it's 1, we're not even going to get an answer. We can't do that division. Right? And if it's greater than 1, we get output being negative, which is a little silly. And so clearly we need that assumption. And so the math tells us what we were implicitly assuming when we were doing this story. So back in the day, way back in the day, in the 30s and 40s when this thing was popular, math wasn't part of economics, wasn't part of how social scientists approached anything, with a few weirdos, of course, but by and large. And so what happened is they tell the story, and you could tell the story, but it was never exactly clear what assumptions you were really making about human behavior. Right? That somewhere in the back of your mind you'd have this idea that when people got richer, they didn't spend as much of their, they spent some of it, but they saved some of it, right? You might have had that, but it wasn't necessary to make it explicit. But when you force it into mathematics, the math forces you to be extremely logical about how you think. And so you pick up all these things that you were just sort of implicitly assuming without thinking about it and find out what they really were. So we really do need this assumption. Now, I'll argue that as assumptions go, this is one of the least problematic ones. For an individual, it could be wrong, but for society as a whole, in normal times, hasn't been found to be an issue. Could be, though. I guess potentially could be, but hasn't been found to be an issue. Okay. The other thing that we get out of math that we don't see here is that sometimes back in the day when they were doing things without math, they would come to very, very nice conclusions and stuff, and most of the times they were right, but some of the times they were wrong, right? Because, again, the math forces you to think very logically about things, and sometimes that brings out that you're making mistakes. Right? That you're bringing in 2 inconsistent assumptions. Like if you have a complicated story, at one point you're sort of in the background, have one idea, and at some other point you have another idea, and these things can sometimes be inconsistent. This came up. So in the 50s and 60s, when sort of math took over social sciences, first economics, then other social sciences as well, a lot of things that we thought we knew turned out not quite so true. Right? And so it's very useful for those 2 reasons. Right? You can see exactly what assumptions you need to make, and you're going to think very logically about them. On the other hand, have you learned anything? No, you have not. Welcome to class. Enjoy your university experience. You have not, because we have proven that this is why, but we don't understand why. Right? And we need to understand why. We need to understand what's going on and see if there's anything we can learn from this. Right? You learn to do a little math. Lovely. Good for you, but you're not shocked about that, right? So what can we learn from this? Well, while we're here, I want to point out that we have this thing, 1 over 1 minus c. And this thing, we're going to call the multiplier. I'm going to go nuts. Multiplier. It'll be fun for you watching me go nuts. Good day. Good times. Good times. Okay. You can take bets on when I start screaming at the computer. It'll be here. So this 1 over 1 minus c is what we call the multiplier, or the government spending multiplier, or the autonomous expenditure multiplier, or something like that. And why? Why? It is multiplying E. See, it's a multiplier. It multiplies E. And that's exactly why it's called the multiplier. We're deep. We're deep. We have really good at naming things. That's the way. But it turns out this is important, right? Because what is this thing? So suppose the screaming starts soon. Suppose C is equal to 0.9. Okay, which is a reasonable thing to think it might be, that marginal propensity to consume might be in that neighborhood. Right? In that case, 1 minus C is equal to 0.1. 1 over 1 minus C is equal to 1 over 0.1 is equal to 10. So in that case, our multiplier would be 10. So what does that mean? Well, it actually does have a meaning, right? Because this is multiplying, it's multiplying something, that's how it got its name, but it's multiplying E, which is all this autonomous expenditure. And so what was E? E was equal to what? It was equal to C bar minus CT plus IP plus G plus net exports. Right. So all that stuff, all that autonomous expenditure. And it is sad and pathetic state of my life that I could just do that without looking back, but please don't be able to do that without looking back. It's just too many years of teaching this. But that's all the stuff that was multiplying this 10, right? So it's going to be 10, output is going to be 10 times this, which is fine as far as it goes, right? But what if these things change? For example, what if government increases spending by 1 billion euros? Well, then output goes up by 10 times that change. So output in the economy goes up by 100 billion euros. So if we change spending, if we change any of these autonomous expenditure bits, output is going to go up by 10 times that amount. So if people become pessimistic about the future, and so C bar goes down, they say, next year I'm going to be fired, very likely, so I better save now. Let me lower my autonomous expenditure. Right? They start spending less just because of pessimism about the future. Nothing real happened. They lower their spending by 10 billion. Output goes down by 100 billion. Right? So small changes in autonomous expenditure can have really large changes, large effects on output. And this is why the multiplier is so crucial. Okay? That's mathematically. We, of course, want to know the story for this. Right? We're not happy with this, but you know, it's all right. Just to do another one, just to get the idea. Suppose C is equal to 0.95. Also a very reasonable number, right? Then 1 minus C is equal to 0.05. 1 over 1 minus C is equal to 1 over 0.05, which is equal to 20. Right, so the multiplier is higher. Okay. Now, there are those of you, I know, that are thinking, okay, I'm just going to memorize this formula. Please, God, don't. Don't memorize this formula. I can change this model very easily, and you'll get a different formula for the multiplier. There's nothing super special about this, but because we can have different formulas with different versions of the model. This is the simplest possible version of the model, but we're going to fancy it up pretty quickly here anyway, and it will become more interesting and realistic as we go along, but there's nothing worth tattooing on your arm or anything about this. You won't be asked to memorize it or anything like that. You will be asked, by the way, to know whether an increase in marginal propensity to consume is going to increase or decrease the multiplier. But don't memorize that either. We're going to understand that in just a minute. Okay, so that's our multiplier mathematically. Okay, questions about that? Okay. Now let's do it graphically. Well, we've got 3 ways we want to do it. We want to do the math, we want to do the graph, we want to do the story, right? And so here I have a particular example. And it's going to be helpful. Let's see. And so we got C plus I plus G plus net exports. And I've put all the autonomous bits and called them 950. So that's your your C bar and your IP and your G and then NX. That's our E, is 950. I just totally made this number up. Good for me. The imagination on this man. Just totally made up a number out of nowhere. It's amazing. All right, so, and then I totally made up that the marginal propensity to consume is 0.8. Right? And so then, this gives us an expenditure line, which is all the planned aggregate expenditure. It's the consumption function plus all these other autonomous expenditures. Right? The consumption function looked like this. We add in a bunch of constants. It just shifts that line up. So there we have our expenditure line. If here, in terms of this, we're thinking of output as income. Right? We're thinking of this as income. For different levels of income, the economy is going to spend different amounts. If income is 0, they're all going to spend out of their savings. There's going to be investment. Some foreigners are going to buy some stuff, and they're going to spend 950. Right? That's the IG, net exports, the autonomous consumption all lumped together, 950, even if we have no income. Okay? And then as we get richer, if our income was higher, we're going to spend more. And the slope of this is the marginal propensity to consume, just like it was in the consumption function. That is, if we get one more rich, we're going to spend 0.8 more. So the slope of this is 0.8, this number here. Okay? Then we have the expenditure there. Glorious, glorious, glorious. And then what we're going to do is we're going to say, okay, that's all well and good. That's a story about how people behave. Right? If they have this much income, here's how much they buy. If they have that much income, here's how much they buy. But how much income do they got? Well, we got to figure that out, right? Which is what we did mathematically on the last page, but now we want to do it with a graph. Okay? So how do we do that? Well, we have to say, well, we know something more about this economy, right? This is people, individual behavior, they're going to do this, but we know for the economy as a whole, income and expenditure have to be the same for the economy as a whole. Right? So let's force that to be true, because we know that that's where does income come from? It comes from people spending at stores, and that's where the income came from. Right? You made something, you sold it, that's where your income came from. It must be also the expenditure that people spent at stores. Okay, so we can do that. Do we have? Oh, okay, I have a whole slide about this. Okay. Blah, 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 blah. Well, I can do that like this, by saying we want a place where income is equal to planned aggregate expenditure. So again, here we're saying the y here is income. This is, again, we're thinking of this as income. So we want all the places where income and planned aggregate expenditure are the same, because we know in the end that has to be true for the economy as a whole. Right? So now we want both those things to be true at the same time. We want income and planned aggregate expenditure to be the same, and at the same time we want people spending the amount that they want to spend. So we put the two lines together. Well, a whole different thing with two lines together. One more thing to say about this. This is the important thing. 45 degrees it's not like we're going to do trigonometry on this. Like you're not going to have the arctangent of this or anything like that. It's just that is what makes makes this the x-axis equal to the y-axis. Right? So don't be thinking there's going to be tangents and sines and cosines. There's not. It's another way to represent this fact. Right? All the points where output and planned aggregate, income and planned aggregate are the same. So they're the same if there's 0. If you have 0 income and 0 expenditure, that's equal. If you have one income and 1 expenditure, that's equal. If you have 10 income, 10 expenditure, that's equal. We've just graphed all the places where they're equal. Okay. If 45 degrees makes you happy, you can put it on there. If it doesn't make you happy, forget about it, you're fine. Okay. It's this story that we're graphing. All right. So now we put these two things together. we've got, oh, I've changed the numbers here. That's it. Yeah. So we've got our 45-degree line, we've got our planned aggregate expenditure line, and there is a magic point where they cross. Right? This is the nature of economics. We want people to be spending the amount they want to spend, which is the blue line, and we want income and expenditure to be equal, and that's the red line. And so to make both of those things true at the same time, we must be on both lines. And because this line, the blue line, has a lower slope than the red line, there is only one point where they cross. That's our equilibrium output. Okay? And that's exactly what we did mathematically, by the way. We said we have our planned aggregate expenditure. Right? We have planned aggregate expenditure is equal to E, that's 960 here, plus C times Y, 0.8 times Y. Okay? That was our blue line. It was a math for our blue line. And then we said also Y is equal to planned aggregate expenditure, right? And we put those two equations together. And by putting those two equations together, by plugging this one into that one, we are saying we want them both to be true at the same time, which means we're looking for points that are on the blue line and simultaneously also on the red line. And we're doing exactly the same thing in the math as we're doing in the graph. Whichever one, yeah, you need to know them both, is the bottom line. But you know, they're exactly identical. Right? They're telling you the same information. Okay? And then we get our little magic point where they cross, and that's glorious. Okay? And where did this 4,800? This came from solving the math. All right. So that's all well and good. But now we want to use this to sort of understand what's going on in the economy. And so the way we're going to do this, and this is typical, not universal, but 98 times out of 100, the way problems come up in theory is either explain me why we do this, why we set up the theory this way, or what theory is actually typically used for is saying, here's our little story about the world. Imperfect and simple though it is, hopefully it's capturing something real. We set out, we look at this, I don't know about you, but I'm not particularly thrilled that it comes out to 4,800. Means nothing to me. If it came out to 6,900, I wouldn't bat an eye. Right? It wouldn't change my day in any way. Nobody cares, right? It's just some number. Okay? Where things get interesting is when we start using this to understand how changes in stuff affect the economy, right? So we want to say, here's our story about the world, set it up, and then something changes. And then what is the effect of that change in this story? And that is 98% of the sort of theory questions are, here's the world, telling you which model to use, directly or indirectly, and then saying, here's something that changes, how does this affect the economy? Or how does the model predict that this affects the economy? Okay. And so the thing that we're going to change here is we're going to change something, and then we're going to suppose that people become pessimistic about the future. They just start thinking, for whatever reason, that the future is not so bright. Maybe they got good reasons for it. Maybe it was just a bad dream. Who can say? But they start being pessimistic about the future. Maybe it's some radio guy, keeps talking. But they become pessimistic about the future. So they think their job prospects aren't great next year. They think that maybe they'll get fired. They certainly won't get a raise. All this kind of thing. They're all stressed. And so they want to save more. And so at any particular level of income, nothing bad has happened at the moment, but at any particular level of income, they're going to spend less than they did before. Right? So graphically, what this means is that at each level of income, 0 level of income, they were spending 960. 4,800 level of income, they were spending 4,800, and so on and so forth. At any particular level of income, they're going to spend less than they did before. And that's going to shift things down. Okay. So I think it's helpful if I draw this out. I think the graph is... So we have income here. Planned aggregate expenditure here. I'll try to keep the colors kind of consistent. We have planned aggregate expenditure is E plus CY. We've got we got Y is equal to planned aggregate expenditure. That is our little 45-degree line. And this is our initial equilibrium output. That's our little equilibrium output there. Okay. And then something changes. Instead of it being autonomous expenditure being 960 like it was before, E goes down. So I'm going to make this in green, and we're going to shift this whole thing down. God help us. Nope, we're going to do that again. Okay. Okay, I'm struggling here. And I'm struggling because computers hate me and I hate computers, but because I want to make it parallel. I want to make it a parallel shift down. And clearly I didn't accomplish that. But I want this drop here. Say this is a drop of 10. I want it to be just the same is this drop here, also a drop of 10. The whole thing just shifting down parallelly because it's autonomous expenditure that went down. Right. Okay, so what happens is output goes down we went from the initial planned aggregate expenditure to planned aggregate expenditure prime. And output went down from Y to Y prime. Okay. Lovely. Now, we know from the math that output drops by the multiplier, in our case 1 over 1 minus C, times however much this expenditure changed, autonomous expenditure changed, in this case 10. Right? So this is going to be 10 times the multiplier. We said C is 0.8. Which means 1 over 1 minus C is equal to 5. I can get that to right. It's equal to 5, which means output should go down by 50. Right? And we want to see this in the graph. So at the moment, we got output definitely goes down. Right? We can see, just graphically, we can see output is less than it was before, which is itself something worth knowing. Right? People become pessimistic about the future. It is not just them that it affects, but it affects the economy as a whole. Output goes down. But we want to see graphically. We're not going to be able to see the 5 times it. We're not going to see that output goes down by 50. But we will be able to see that it goes down by more than the amount that autonomous expenditure fell. Okay? So this is what we want to see in the graph here. We want to make it clear. You want to convince yourself graphically that output has to fall by more than 10. So how do we do that? Well, we shifted down the curve by 10, right? Everyone can agree on that. Let's see, get a color that's not used so far. Oh, we'll do purple. So this distance here is 10, right? Because that's how far we shifted the thing down. And so if I carry this over here, because this red line is a 45-degree line, God help me. I know that this distance here is 10. Right? Because everything on this line is output and income are the same. So if output along that line fell by 10, on that red line fell by 10, then output fell by 10, then staying on that same red line, income must have fell by 10. But of course, output fell by more than that. We can see this graphically. Right? So if output had just gone from its initial point to here, it would have gone down by exactly 10. But it went down by more than that, which is this multiplier phenomenon. Okay. How are we doing? Yeah. So that's our two ways to see this. And we have one more way to see this, which is the story of how this works. Yeah, and there's just sticking numbers on it. Right here we see it going down by 50. Okay. And so this is going to be our sort of baseline story for where recessions come from. People, for whatever reason, become pessimistic about the future. They stop spending as much as they were before, and this causes output to fall by more than the amount that they stopped spending. Okay. But we still don't know why it falls by more. We've seen mathematically, we've seen graphically that it falls by more, but we haven't explained why. Okay. All right. So let's do it the other way, because increases are easier to do than decreases. Let's suppose that people become optimistic about the future, and they increase their autonomous expenditure by 1. Okay? A 1 unit increase in autonomous expenditure. And we know from the math and we know from the graph that, okay, this is going to reverse everything, but output should go up by more than 1. Right? Now, one thing to do when you're studying, by the way, when you're studying the graphs, a very useful thing to do is to do the opposite thing that I did on the graph. So I did what happens if people become pessimistic about the future on the graph. You should go through and do the same graph, learn that, and then do the same graph if people become optimistic about the future. And if you can do that, you know it, you're done, go and do something else. Right? But if you can't do that, then you didn't quite internalize it yet. So that's a very good way to check whether you're understanding what's going on, is to do the opposite things that I did. All right. So we have a 1 unit increase in autonomous expenditure. This is just what the multiplier is. I'm just saying what it is again. Okay. All right, let's do it this way. Let's do it. Let's do the same thing as the graph. People stop spending 10. This is what we did in the graph is what we did in the math. Right? So people stop spending 10. Why does output go down by more than 10? Well, remember we have this barbershop story of the economy. Right? Nothing gets produced until someone walks into the shop. Right? And so if people stop spending 10, it means they're not getting their hair cut 10 times. That's 10 haircuts that aren't happening. Those haircuts never get produced. Okay? But because of that, the barber is sad. He doesn't have income. Right? He used to be cutting everybody's hair. Now he's cutting 10 less hair than he was before. Now he feels poor. And as a poor person, he does whatever a poor person does, which is to cut back his spending himself. Right? So initially, you stop getting your hair cut. Good for you. And then he feels poor, and so he stops getting his haircut too, or he stops going to the pub, or he stops doing something else. So his spending falls by marginal propensity to consume times 10, in this case 0.8. Right? So his spending falls by 8 because he feels poor. So that initially we had 10 didn't get produced, but now another 8 doesn't get produced as well. Okay? And of course, he used to go to the pub. Now the publican is sad because he used to have a customer that was spending 8. Now the customer's not spending 8. And so he feels poor. What does he do? Well, he feels poor by the amount that his customer stopped coming, which is C times 10, 8. And so he feels poor by that much. And so he does whatever a poor person does, which is spend less than he otherwise would. In this case, C times the amount that he feels poor, which is C times 10, C squared times 10. So that's 6.4. Right? And so we have this initial effect. People stop spending. That's the amount that output would go down if that was the end of the story. But in fact, that makes somebody feel poor, so they stop spending. Makes somebody else feel poor, so they stop spending. And so on and so on and so forth. Okay, so that's our story. How are we doing? That's our story. So, I told you that you were supposed to be able to tell me if marginal propensity went up, does the multiplier get smaller or bigger, right? One way to do that is to tattoo it on your arm. But another way to do that is just to tell this story, right? This is the story of the math. This is the story of the graph. It's telling exactly the same thing. It's saying, look, suppose people stop spending. And suppose, for example, the marginal propensity to consume was 0. Nobody paid attention to their income at all when consuming. We're looking at you, Bill Gates. Right? He's got the wealth. He doesn't need to worry about this year's income when he decides on how much he spends, unlike many of us. But if we didn't, if people's income didn't affect their spending at all, marginal propensity to consume of 0, then what would happen if people would stop spending 10 less, they stop spending 10, that would be 10 less haircuts that got produced. And then the barber would feel poor, but he wouldn't change his behavior in any way. And so that would be the end of it, right? Because C times 10 would be 0. No change in behavior. And so the total effect on output would be just 10, the initial amount. So if marginal propensity to consume was 0, the multiplier would be 1. That is, you change autonomous expenditure by 10, output changes by 10. Okay? It is because this guy changes his behavior when he feels poor that we get this multiplier. And then he feels poor, so he stops spending. So the next guy feels poor, so he stops spending, and so on. So if we make the marginal propensity to consume very low, the multiplier is going to be very small. If we make the marginal propensity to consume high, that means this second effect is going to be high. Right? If he spends just basically every cent that ever comes in. And so people stop getting their hair cut. He feels poor by 10. He cuts his purchases at the pub by almost 10, 9.99. Then that's going to be a huge effect in the second stage. Right? And that's going to be a huge effect in the third stage, and the fourth stage, and the fifth stage, and so on. So if marginal propensity to consume is really high, then the multiplier is going to be really large. Okay? It is this sort of argument you should be able to make, and I should be able to ask you all kinds of things. I could set up a thing that says, what if foreigners start liking our products more? And you should be able to trace out how this affects the multiplier. Right? Lots of different stories I could tell, stories that I haven't even told you yet. I could ask on the exam, and you just do this exact same thing. You say, if people become poor by 10, if they stop spending 10, what is the next step? Somebody's going to feel poor. How do they behave? If they change their behavior a lot, the multiplier is going to be large. If they change their behavior only a little bit, the multiplier is going to be small. And you don't have to go through all the steps. You just go through first step and second step, and you're done. Okay. Okay, I'll give you a 15-minute break, and we will do the math for this after the break.
A few moments later.
The light has returned to people's eyes. So this is our story. This is the punchline of this whole chapter and sort of the building blocks for a lot of macroeconomics. This is just a starting point, but this is what the point of this is. And so now it's worth thinking a little bit to ourselves. Does it capture something real? Doesn't it capture something real, right? So the story is, again, if, for example, people become more optimistic about the future, they start buying something, or you get firms to start building buildings downtown. So the government's always trying to get firms to build buildings downtown, build some office blocks. Now they're optimistic about the future. They think all those London businesses after Brexit are going to come to Dublin. They start building office blocks downtown. What is the effect of this? Well, first thing they do is they build office blocks. And so that is a change in autonomous expenditure. We're now increasing investment. So as we increase in investment, that means more stuff gets built. Now they increased investment by 10. 10 office blocks got built. Lovely. But then the people who are building the office blocks, the construction people, they feel rich. And so they go out and spend some money as well. They go out and they buy a house. And then the person that builds houses feels rich. And so he goes to the pub. The publican feels rich. He goes out to and so this initial investment of 10 for the office blocks ripples through the economy, and it gets spent over and over and over again, a little less each time because people save some, but they spend some. Right? And we need them to save some, otherwise the whole model doesn't work, in a way that we'll see in just a second. Okay. So we have, is this going to be, I have to click on something? Let's see. All right, here's a bunch of stuff, but let me do it by hand. So let's suppose that the initial change in output is delta E. That's our initial change in expenditure. And so now we're wondering, how much does output change? Output change on a whole. Well, we can do this same story in a different way. Do it the same way as we did in the story. We say, well, initially, we're wondering what happens to Y. So what is the change in Y? And we can just do these various steps. So the change in Y is initially just the change in expenditure. We start buying office blocks. We buy 10 office blocks. 10 office blocks get produced. Right? We become pessimistic about the future, negative delta E. Then we don't buy that stuff. That stuff doesn't get produced. Those haircuts don't get produced. And that's direct. And then we get the first stage, which is the guy that was building these office blocks, he feels rich. And so therefore, he does what a rich person does. He feels rich by the amount that we change the expenditure, because that's how much work he got. And so he's going to do what a person does when they feel rich, and he's going to change his expenditure by C times delta E. Right? Delta E is the amount that he felt rich. And marginal propensity to consume times that is how much he changes his behavior, how much he changes his spending. When he feels rich, he buys more stuff. How much stuff? 0.8 times the amount that he feels rich. The marginal propensity to consume times the amount that he... So he doesn't spend all of it, he saves some, but he does increase his expenditure. And of course, the person that he buys stuff from, that person is going to feel rich, right? That person is going to feel rich by the amount plus C delta E. Right, because that's the amount that his customer changed his spending. And so he's going to do whatever a rich person does, which is buy some more. Not he's going to spend all of it, but he's going to spend some of it. So he's going to change his behavior by C times the amount that he feels rich. That's the second step. Third step. So the first step was a direct effect of the change in expenditure. Second step was the first guy who felt rich, who was selling to the initial guys, and then the people who he was buying from. And then, of course, we have a third guy who feels rich by that amount, and he changed, because that is this thing altogether, C squared times delta E. So he starts spending by that much, and so this guy feels rich by that much, and he changes behavior by C times that. And so on and so on and so forth. So our whole thing is delta Y is equal to delta E plus C delta E plus C squared delta E plus C cubed delta E, and so on and so forth. C to the fourth, C to the fifth, C to the sixth, and so on. That's the total change in output, is this. Okay. Now, I don't know, secondary school, what math classes you guys had. Some people had it, some people don't, but there's a whole theory of infinite series. And what we have here is an infinite series. Y is change in E plus this, plus that, plus that, plus that. And they're getting smaller each time. And there are rules, mathematical rules, for when these things converge to a number, when they don't. In our case, it's going to be pretty easy to deal with. We don't have to know all that theory. We can deal with it directly. So whether you've had that, and you've had infinite series before, and you can just solve this because that's something you saw in secondary school, glorious to you. You can tune out for a few minutes. Or if not, like, stick with us. It's not too bad. We're not going to do the whole theory of infinite series, of course, but we can do something with this. And what we're going to do is we're going to say, to solve this thing, to find out what change in y is we're going to notice that all of this stuff, all the way out into infinity, they all have a c times them. This one has one c, this one has two c's, this one has three c's, four c's, five c's, but they all got at least one c. And so what I'm going to do is I'm going to factor out that c. I'm going to take that c out of all of those guys, and what I get is change in y is equal to change in E plus C. And I'm just going to take a C out of each of these things. So the first one is delta E. That's this one here, plus C delta E. That's that one there, plus C squared delta E. That one there. God help us. And so on and so forth. And just factoring out that C. All the stuff that has a C multiplied by it, factor it out. Okay? I can do that. You can do anything you want. No one can stop you in math. Doesn't mean it's a good idea. Well, why did I do this? Well, because then we look at this thing, and that looks just the same as this thing. Those two things look the same. Look the same, are the same, right? And so we can treat them exactly the same. We can just say, well, the first one was true, right? And so there it is again in the bottom. Look, it's the same thing. And so we can say, well, we can use that equation at the top and substitute out for that. And so I can take this equation at the top and say these things are the same. The thing in the bracket is the same as the thing on the right-hand side up here. And that thing on the right-hand side is equal to the thing on the left-hand side, whatever that thing is. And so I get y is equal to the change in E plus C times the bracketed term. And the bracketed term is just this, which is the same as the left-hand side, which is change in y, like so. Because this bracketed term is the same as this. Because it's an infinite series, an intuitive way to think about it, once you take one step, the future looks just the same as it did before. You take another step, the future looks just the same as it did before, just the bygones. So now I can solve, and this isn't y, this is change in y on the left-hand side. So now I got change in y on the left-hand side, I got change in y on the right-hand side. I can solve for the change in y. And that's subtract c times change in y from both sides. Y minus c change in y is equal to the change in E. 1 minus c times the change in y is equal to the change in E. Divide through by 1 minus c, and I get the change in y is equal to 1 over 1 minus c change in E. Okay. And so you see the change in y is equal to our multiplier times the change in E. Just another way to get exactly the same thing. But this time, instead of working from the basic assumptions of the story, that is, y is planned aggregate expenditures, c plus y plus g plus net exports, c is this formula. Now we're working from the story where you spend a little more, that much more gets produced, somebody feels rich, they go out and do what a rich person does, which is spend more. That means that somebody else feels rich, they spend more, and so on and so on. It comes to the same thing. Right? Hey, so your question for yourself, not like, obviously it's a class, you got to regurgitate the things for the exam and all of that, but you should think, do you buy this? Is this something that goes on? I don't know here, but in the US, there's always sports teams that are dreaming of having the government buy them a stadium. And so they'll go and they'll say, we bring so much wealth to the neighborhood, right? Your town is based on us, right? We have a game, and then people come and they spend some money, but it doesn't stop there. They spend the money, and then they stay in a hotel, and the hotelier feels rich, and he spends money, and it circulates through the economy. It's exactly the same argument as we have here. Right? Now, you can buy it or not. Now, I'm a little bit anti-sports biased. Sorry about that, but I just am. People were mean to me in high school. I'm just saying. Anyway, I have an anti-sports bias, and so I'm always like, it's not true when the sports guys say it, but it's true when I say it in class. Well, it's the same story, right? It's exactly the same story. And we can debate, but you can decide how important you think it is, right? Where it's coming from is these two things. One, we have everyone meeting, and we have some silly assumptions that went in here, right? We said we have these preset prices. Nothing gets produced until somebody comes. That's important. And then we're saying that people buy stuff based on their current income. And so when somebody comes and buys something, my current income goes up, I go and spend. Right? The first one, obviously silly. A simplification of reality. Second one, well, you can have your opinion. I think most people, this is my opinion, which is for what it's worth, not as valuable as your opinion because it's a class for you. But my opinion is like a lot of people I know kind of spend out of their current income. If their current income goes up, their spending goes up. Maybe not in the simple way that we have here, but that seems to capture something about people I know. Okay? I might know weirdos. Probably do. Not one-to-one. Like I have a friend who got a very good job and now is saving for a house, and so his spending went down. So, it can happen either way, but on average, I don't know. You decide whether you think it captures something. Okay? This is the big punchline of this chapter, and it's what we're going to be building on as we go. So you really, really need to get comfortable with the three ways of thinking about the multiplier. Right? We have the math. We have two versions of the math, actually, coming to the same thing. We've got the math. We've got the graph. You should be able to see that output changes by more than the shift in the curve. Right? You should understand why the curve is shifting the way it does, and you should be able to see that output changes by more than that. Okay? The only way to do that, by the way, to come to grips with that, is to do it yourself. And here's how I suggest you do it. What I suggest you do is you get a piece of paper, big piece of paper, like waste paper. It's nothing compared to Miss Swift on his airplane in terms of environmental damage. Go into the recycling. Get a bunch of paper out of the recycling. Go on the back. You never know what you find, by the way, if you go to the recycling and take some paper out. Like, we found everyone's salaries. Anyway, you can find all kinds of gossip in there. So go in, rubbish through the trash, take out the paper, and get a clean piece of paper, and on that piece of paper, draw the graph. And the graph looks like what? Y, planned aggregate expenditure. And we are thinking about this as income. Okay? And just draw that, just that. And think to yourself, why did we put those two things on there? Why are those the things that we're putting on our graph? How does that relate to the story that we're telling? Okay? Then, set that paper aside. Very important. You're going to want to draw the whole graph right away. And that is almost always a mistake. If you're looking at the book, it'll have the whole graph right away. But there's a bunch of steps in there, and if you're looking at the whole graph right away without understanding each of those steps, what you do is you tend to memorize it rather than understand it. And that will cause you troubles, right? Maybe not. Maybe you're good at memorizing. I don't know. But I think it is better to like set that aside. Just set it aside, get another piece of paper, and draw it again. And draw your first line. Okay. Draw your first line. Why did we draw that line? What's the story for that line? Because this is a story about human behavior. Right? It's a very simple story about human behavior. But on a separate piece of paper, you got this, and we're just trying to understand that line. Why is it upward sloping? Why does it have that intercept? What is the slope of this line? Why does the slope of that line behave the way it is? What are the stories involved in this? Right? So you got a bunch of stuff. Why the intercept? Why do we think that planned aggregate expenditure is related to income? Right? That's going in there. What kind of slope does this thing have? Okay. What are the stories involved in that? Okay. Then, from the recycling, so you're not hurting the environment in any way, draw another graph. Looks just the same as the other one. So you are going to be tempted to continue on that same piece of paper, but just trust me, don't. Right? Make it a separate thought. And by making it a separate piece of paper, you make it a separate thought. Okay? If you're just doing it on, you'll rush. If you're doing it all on the same piece of paper, you'll rush. You'll skip steps. You won't understand what you're doing. And then you won't have a firm foundation. Right? None of this takes very long. The whole thing can be done in 20 minutes. But go through the steps. Like, get a new piece of paper. Whole new piece of paper. Draw this thing again. And say, we know that we saw this thing shifting around. So what kind of things would make this, what kind of changes in the world would make this thing shift around? What would make it shift up? What would make it shift down? Would it rotate? Would it shift parallelly? What stories are we telling about it shifting around? Okay. Since this is a line that is telling us something about human behavior, our story should be something about human behavior. Obviously simplified, but it should be something about human behavior. Then, you know what you got to do. You got to rummage through the trash again. You know you do. It's rough for you guys. Got your income. Got your planned aggregate expenditure. We have another line, this 45-degree line. What's that on about? Why did we draw that? Why do we think that's something that's true? Okay. In this case, it's not a story about human behavior. It's about aggregating up the economy. So it's not going to be shifting the same way the other one was. If it was another line that was shifting, which we'll get later in the class, you would want to go through that same exercise for that as well. Completely separate. Notice I'm doing it completely separate from that other line that we drew. Because we want to understand each line individually and then bring them together. So why do we draw that? What's going on with that? And then, only then, when you've dealt with each and every individual part of the thing, put them together. Why do we think that is the level of output that we're going to get? What's with that? Okay. At this stage, that should be fairly direct because you've gone through what each of the lines mean. But why? Why is that something we're doing? Okay. And then, new piece of paper, new piece of paper. And I suggest, by the way, and I'm being a little pedantic about this, but you should too. I've been drawing what's on the axis each time I've been drawing these things on. You should do that. You should always draw them on. You're reminding yourself what it's about. It is not just a bunch of shapes moving around. It is a story. You want to remind yourself that it's a story. And then, remember, we talked about what makes things shift. You had a whole piece of paper that was talking about what makes this curve shift. Then put it together with the shift in this curve. What makes the curve shift? How would that affect the economy? And try various shifts and see that. And again, what you want to come out with from all of this is you want to look at the multiplier. Right, you want to see that output changes by more than the shift. So we're going to have a bunch of graphs. And when you're learning them for the first time, and even after 30 years, it is really helpful to disaggregate them, to separate them out, because each line on that thing represents something different. There's a reason why we put what we did on the axis. We could put anything on those axes as we want. We chose to put those things. So there must be a relationship between those things. What relationship are we expecting to find? Right? Why did we draw this curve this way? Whose motivations are there? What is that encompassing? What stories are we putting into that? Okay. And then if something changes in those stories, how is that curve going to react? Okay. And each of the curves on the graph, or the lines on the graph, always represent something different. So we want to look at them separately before we put them together. And this is the beauty of the graphs, actually, why we do the graphs, is it allows us, the graphical stories allow us to separate those two things out. Right. We have a story that represents this one line, and typically we'll have a story that represents some other line, is represented by some other line, and the graph allows us to put those stories together in a consistent way. We are making those lines in order to separate those stories in our mind, right, and keep them disentangled. And so you should do them disentangled. What is this story? Completely separate, different piece of paper. What is that story? Then put them together. Okay? And what makes something change? Okay. If you can do that, if you can do the shifting up and shifting down, you know why they're shifting up, you know why they're shifting down, you know, you can see that the output changes by more than the shift. You're good. Move on with your life. Okay. This, by the way, will not take you forever, right? But I just want to slow you down a little bit, because the way people tend to study, is they look at the book, there's this graph in the book, they draw out the graph, and they say, I don't understand this graph. And then they can be stuck for hours, because it's not about understanding the graph, it's about understanding each individual line on the graph. And then the graph itself is easy. But if you're just trying to understand it as a whole, there's a whole bunch of stuff in there that is very hard to disentangle on its own. That's the beauty of the graph, is that it helps you disentangle it. Right. And then we have the story, and it's important that you understand the story, because that is how you will answer some certain kinds of questions on the exam, and also because what's the point of the whole thing if we don't understand the story, which is output. You know, we start buying more stuff, that makes output. Somebody feels rich, they start buying stuff, that makes more output, and so on and so forth. And so it's fairly simple to answer questions about if this thing changes, say the marginal propensity to consume or something else, say the tax rate changes. Does this make the multiplier bigger or smaller? Well, let's do tax rate. Suppose instead of having these sort of lump sum taxes, where we just say everyone pay us 10,000 euros, we had more normal taxes, income taxes. And so every time you earned something, you had to pay 40% to the government. Right? That's how our real taxes work. Right? Would that make the multiplier smaller or larger? Would higher taxes make the multiplier smaller or larger? Well, I don't know. I didn't memorize it myself. But I would go through the story. And this is what I'm going to do. I'm going to go through the story with an audience. It'll be glorious. So they start building. People become optimistic. They start building these buildings. The first effect, 10 buildings get built. Output goes up by 10. The construction workers feel rich. If there were no income taxes, they would feel very rich and buy a lot of stuff. But the government comes and steals half of their money. Bastards. And so now they don't feel as rich as they did before, without the taxes. So they don't buy as much stuff. So that second effect is smaller. So having income taxes, the higher income tax we have, the lower the multiplier is going to be, because that lower the second effect is going to be, and therefore the lower the third effect is going to be, and so on and so forth. Okay? Okay. So it's not hard to figure out. I know that went by really fast, but practice. Right? You try it a few times. Like go through that story with different, it's your first time, go through it with different marginal propensities to consume. If marginal propensity to consume went up, would the multiplier go up or down? Convince yourself. Do the tax one. Would it go up and down? Here's one you can do that I won't tell you the answer. What if Irish people started liking foreign goods more? Right? They learned about sushi, and all of a sudden they want to import sushi nori. Whenever they're going out, they're importing foreign foods because of this Ryanair thing that flew them all over the world. Now they love this stuff. And so now they like foreign stuff more than they did before. Would that make the multiplier go up or down? Okay. Not going to tell you. This is a thing for you to think about yourself. You can come back to it if you want me to, but this is one to try for yourself. Okay. So that's our multiplier. That's our sort of big punchline here. How are we doing? And now we want to talk about what kind of policies this sort of implies for us. So in the Keynesian model, recessions and expansions are caused by too much or not enough spending, or vice versa, right? Recessions are caused, people just decide not to spend, therefore that has a multiplier effect through the economy, and output falls by a lot. And if we sort of decide to spend a lot, output's going to go up by even more than that. So this is the cause of recessions and booms, is fluctuations in spending. And this can be consumers. It can also be firms varying investment. They become pessimistic about the future. They don't build a factory. Whole economy shuts down, and they say, see, look, I was right. The whole economy shut down. But it was, anyway, so that's where they come from. And so a lot of macroeconomics is focused on stabilization policies. And these are policies saying, like, ideally, we would like to produce more stuff with less effort. We would like potential output to go up, the normal level of output to go up. These are long-term policies. But in the short run, what we can hope for is maybe not have these giant crashes where everyone's unemployed. And let's stabilize things around potential output. And then we can do long-term policies like education and stuff to get output to go up long-term. But let's keep things stable at the moment, right? So a lot of macroeconomics focuses on these stabilization policies. Okay. So these are government policies trying to eliminate output gaps. So just in jargon, expansionary policies would be policies that try to expand the economy. Contractionary policies would be policies trying to contract the economy, make output lower. Right? There's a lot more talk about expansionary policies rather than contractionary policies, partly because of this general bias that says higher GDP is always better, which is, of course, rubbish. Right? We don't want to be slaves. But there is a lot of that. But there are talk about contractionary policies. There are, for example, a lot of people that think that if output gets too high, like well above potential output, that can actually cause a recession later. So even if things look fine at the moment, it's actually leading up to troubles later on. So contracting things, like not letting it get too far above potential output, not getting, can be something that people think is worthwhile. So we're going to talk about a number of tools for stabilization policy. The two broad types of tools are monetary policy and fiscal policy. Will we have a slide about this? So fiscal policy is the one we're going to start out talking about. And this is playing around with the government budget. So government can spend more, it can tax less, it can do various things with its budget. Now there's a lot of reasons why government spends money. Right? Government spends money, for example, because they want to have a new hospital. Right? That would be lovely. Or they would like to have a fire department, so they spend money. Okay? And that's all well and good, but we are talking about stabilization policies, so this is spending particularly targeting stabilizing the economy. Okay? So it's all well and good, you want a hospital, but we're also going to be using our spending to help stabilize the economy. So when we're in bad times, we're going to try to use it to get us out of the bad times, or to keep a recession from happening. So the two tools of fiscal policy are government spending, and this has a direct effect on planned aggregate expenditure. We know this because government spending is, of course, G, and planned aggregate expenditure is equal to C plus IP plus G plus net exports. Look, there it is, right there. So if you increase G, this is one of our autonomous expenditures, output is going to go up. If you say, I'm going to build a hospital, then one, hospital gets built. Two, the people who are building the hospital feel rich, and they go out to the pub, the publican feels rich, and so on and so forth. We get the multiplier effect, and output goes up by more than the cost of the hospital. Okay? A direct effect. But we also have taxes. Taxes are another part of the government budget, and these have an indirect effect on planned aggregate expenditure. Why? Because when we increased government spending, we built a hospital. Directly, a hospital was built. Right? That's output went up by the cost of the hospital. And then we had all these knock-on effects because people felt rich. If, on the other hand, we reduce people's taxes, then nothing happens initially, but people feel rich because their taxes went down and they go out and spend. So you only get the secondary effect. Right? You don't get that initial effect of the spending, but you do get people feeling rich and therefore going out and buying something, and those people feeling rich and therefore going out and buying something, and so on. Okay? But these are our two big tools of fiscal policy. So if you want to increase output, you want to make people feel rich, you either buy stuff, government spending, goods and services, or you lower taxes, and that makes people feel rich and they go out and spend. Okay. Another tool is transfer payments. From our point of view, transfer payments are the same as negative taxes. So this is child allowance, for example. If you just give someone money for whatever reason, right? You're not asking for a service in return, but you're giving them money, redistributing money. That's just kind of like giving them a negative tax for the point of view of macroeconomics. And so that is exactly the same as lowering their taxes from our point of view. It turns out it's not really the same as lowering people's taxes in the sense that people behave, real humans behave differently depending on the source of the income, and there's more target at particular groups and all kinds of stuff. But from our point of view of stabilization policy, taxes and giving people money is basically two sides of the same coin. It's an indirect effect. Nothing got purchased there, but it does make someone feel rich, and that changes their behavior. They go out and spend. Someone else feels rich, and so on and so forth. Okay. All right. Here's what do I want to say about that? So we go back. So suppose we're here, and we think this output is too low. Okay? One thing to notice is that we don't really have recessions in this model. Right? We don't have potential output in any real sense. We didn't bring it in any way, and this is something that's really lacking in this model. And so I can tell stories about recession, but I'm kind of imposing them on top of this model. But suppose we think that normal level of output is 4,800. Okay? And our current level of output is 4,750. Okay? And we want to sort of get to 4,800. Okay? So we can do this with fiscal policy by increasing government spending, for instance. In this model with this 0.8y, the multiplier is 5. We showed that a bit earlier. Right? 1 over 1 minus c is 1 over 0.05, which is, 1 over 0.2, which is 5. And so we want to increase output by 50 So we only have to change spending by 1/5 of that. Right? So if we change spending by 10, that is going to increase output by 50 in the end. Right? So we shift this curve up. We increase government spending by 10, shifting the curve up, and output goes up by 50. That is the initial 10 times the multiplier, which is 5. Okay. Now, we can do that. And if we really believe this model, if we think this is the way the world really works, life is great for us. Because what we can do, if we think, what we would like is for this economy to produce an infinite amount of stuff. So all we have to do is increase government spending by 10, and output will go up by 50. And then we can increase government spending by 10, and output would go up by 50. And then we could increase government spending by 10, and output would go up by 50. And we can keep doing this forever. There's no problem with that. So we can get output as high as we want. So clearly, I think hopefully you're awake enough at this stage to agree with me on this. Clearly, there's something stupid about this model. Right? This is clearly not the way the world works. We cannot get Ireland to produce an infinite amount of stuff by the government just spending more and more and more and more and more. Right? Now, the thing that's, there's many things missing, but sort of the big thing that's missing here from our point of view is going to be potential output. That is, it's all well and good the government spends more and people go back to work, and that's lovely. But in fact, Ireland cannot physically produce an infinite amount of stuff. There's a limited amount of people, there's a limited amount of knowledge, there's a limited amount of effort that we're willing to put in, there's a limited amount of machines for us to work with. All of that stuff is limited. We're not, like, you can walk to the edge and see, like, we can't have an infinite amount of production here. Right? It's just not possible. We might have enough, but we can't have an infinite amount. Right? And so we haven't taken into account that there are resource constraints on this. And this, if you'll remember way back at the beginning, a couple classes ago, this is by design. This is a model designed for the Great Depression, when you could walk down the street, see lines of workers, see empty factories, and so resource constraints weren't really a thing. Right? Or they weren't binding. Like, it wasn't like you couldn't have another factory go to work. You could get another guy to work. There wasn't a problem there. And so this idea of potential output wasn't really relevant to the situation they were in. Right? And so in that sense, it wasn't as bad as it seems now. But be aware that, like, for now, this is a bit goofy. Right? There's definitely reasons. There must be reasons why the government can't do that. One of them is, like, they're going to end up owing, like, where does the money for all this spending come from? We don't know. They just magically poofed it into the air. Right? And so we want to take all that kind of stuff into account to see what restrictions are on this. But, yeah. Okay, I'm going to leave it there so I don't rush through automatic stabilizers, because they're very quick, but they're really important, so I want to give them some space to be important. Okay. See you on Tuesday. Have a good weekend.